viewers. Today we are going to discuss about a contactor and the principle of operations of a contactor. We are going to commence by defining what a contactor is, then we proceed to the other discussions. The contactor is simply defined as an electromechanical device that is used to open and to close an electrical circuit. The contactor mainly is used in the industrial setup. It is used to start up pumps and drives. Now we have two contactors here. One of the contactors here has a part attached to it here which is known as the auxiliary contact, while the other contactor we have here does not have an auxiliary contact. So in a nutshell, some contactor comes with an auxiliary contact attached to it, while others come without the auxiliary contact attached to it, but a provision is made here to house an auxiliary contact. But for our discussion today, first of all, we are going to discuss the basic component of the contactor. The contactor, the unique thing about the contactor is that it has embedded in it a coil that has two terminals. Let's get a closer view so that you can see the terminals of the coils I'm talking about. If you can see clearly now, we have the terminal here, A1, we have A2 here. These two are the terminals of the coil that is embedded in the contactor. Like I told you earlier, this contactor comes with an auxiliary contact. The auxiliary contact consists basically of two contacts: the normally open contact and the normally closed contact. If you watch closely, you see an abbreviation there, NO and NC. We have NC here, we have NO here. That's the input of the auxiliary contact here. We have the output of the auxiliary contact here. You can see the input of the NC here, the output of the MC here. Here we have the input of the NO here and the output of the NO here. So the auxiliary contact consists of two contacts, the normally closed and the normally open. Like I said, the contactor embedded in it is a coil which has two terminals here, A1 and A2. Now, contactors are designed in such a way that they can be operated using a DC supply or an AC supply. The DC supply is fed into the two terminals. That is, if the contactor is designed, that is, the coil of the contactor is designed to take in a DC supply. A DC supply simply means a direct current supply. A good example of a source of a DC supply is a battery. A battery is a very good example of a direct current supply. So certain contactors are designed, their coil are designed to be energized by a DC supply or a DC source. While other contactors, the coil are designed in such a way that the input to the terminals of the coil is an AC supply. An AC supply simply means an alternating current supply. So this voltage source is being fed into the coil. Now the principle of operation of a summary can be said to be as follows. Here, this contactor, if you check, we have 3 terminals here, input terminals here. Apart from the auxiliary contact we talk about, we have 3 terminals here. We have corresponding 3 terminals at this other end. This is the side of the contactor that is connected to the load. While here is the side of the contactor that is connected to the supply coming in. The supply too could be an AC or a DC supply, depending on what the load is designed to take. Now, a contactor, these 3 terminals we have here, they are also contacts. As it is now, these contacts are open. That is to say, a contactor comes with contacts that are normally open. The contacts are normally open. Now what happens is that because embedded in the contactor is a coil, and also we have an electromagnet also inside, and also an armature. I'm going to take my time to explain the internal structure also of a contactor. But for the principle of operation, just a summary of it before we dive into the internal part of the contactor. Now, what happens is that when we feed in supply into the terminals of the coil, A1 here accepts the positive source of the voltage. A2 here accepts the negative voltage. That's why we are dealing with DC. Also AC2, the supply, the lifeline comes here, the neutral comes into A2. When current or voltage is fed into this terminal, the coil is capable of creating a magnetic field. An electromagnetic field is set up in the coil. That is set up in that electromagnet. That force or that magnetic field that is set up attracts the armature. And the armature is attached to this normally open contact. So it drags, that force now drags the armature towards the electromagnet, therefore closing the contact. When that happens, these terminals we have here and this terminal we have here close to create a pathway for the input current here to flow through here to the load. Now, here we have is the internal structure of the contactor, like I said when I was explaining the principle. If you check closely, here we have the coil. This is the coil of the contactor. As you can see, here we have at the terminals. You can see we have 3 terminals, but these 3 terminals here, the terminal here is common. It's common. This is the neutral terminals, while this is the positive terminal. Here is the A1, these 2 are the A2, because it's common. It's just to provide a means whereby you can make your connection of the neutral, either from the top or from the bottom. But basically we have 2 of those terminals, A1 and A2. But here A2 is common. This is the coil. Here if you check, we have the electromagnet here. This is the electromagnet. This is the electromagnet which is placed. The electromagnet is placed inside the contact. Yep. The electromagnet is placed inside, as you can see, to accommodate the coil of the contactor. right here we have is the armature. The armature is connected to the contact of the contactor. Now, like I said, the contactor is normally an open contact that it has. These contacts are made up of mainly copper materials. Now, what happens is that when a supply is sent and input voltage is applied to the terminals, like I said, a magnetic field is set up inside, because what we have here is a spring also. This is how it is enclosed. So when the magnetic field is set up here, it is capable of pulling this armature to the electromagnet. By so doing, the normally open contact becomes closed. As you can see, the normally open contact becomes closed. So this is how the contactor operates. This is the spring, this is the armature, that's the moving part of the contactor, while the stationary part we have here, the stationary metal part we have here, is the electromagnet. So this is how it's been coupled. This is the internal structure of the contactor. Now, earlier I talked about this other contactor not having an auxiliary contact. Now we'll use this opportunity to explain what an auxiliary contact is. Here is an auxiliary contact that is separate from the contactor. Like I said, the auxiliary contact has two contacts, the normally open and the normally closed contacts. Let's have a close view so that you have a better understanding of what this auxiliary contact is all about. If you check, we have two contacts, normally open, normally close, normally close, normally open. So for this auxiliary contact, it has two sets of contacts, the normally closed and the normally open. The normally open contact is open when the contactor is not energized, while the normally closed contact remains closed when the contactor is not energized. But the reverse happens. When the contactor is energized, the normally closed becomes open, while the normally open becomes closed. Now, like I said, this contactor has a provision for us to be able to insert this auxiliary contact. There's a part here that accommodates this in such a way that this part of the auxiliary contact is locked up with this, so that when the coil is energized and the field pulls the armature inside, it pulls along with the contact of the auxiliary contact. So you can insert it like this, open this, slide down, you can see. So when the contactor is energized and the magnetic field is set up around the electromagnet, it pulls the armature, thereby also pulling the contact of the auxiliary contact, hence making the normally open to become closed and the normally closed to become what? Open. next section we're going to look at will be the practical application or connections of the contactor to see how it really operates. We're going to feed in the